Alright guys, what's up? Day 25 of the 100 Days of LeetCode. If you've been enjoying these videos, please like and subscribe. Yeah, let's get right to it. Okay, so we're doing number 162, find peak elements. So a peak element is an element that is strictly greater than its neighbors. Given an integer array nums, find a peak element and return its index. If the array contains multiple peaks, you can return any of them. So you may imagine that nums minus 1 is equal to nums n is equal to negative infinity. So basically, outside of the array, on each side, we have a number that's negative infinity, and this is going to be actually very relevant to our solution. So you must write an algorithm that runs an O log n time. Whenever you see a log n time on a question like this, you're thinking binary search immediately. So we'll look at example 1. That's the array. The output, of course, is 2 because 3 is at the index 2, and 3 is greater than 2. And it's greater than 1, so it's a peak. You can imagine it kind of like a mountain, right? And now we have example 2, we have that, so right away you could return index 1 because 2 is greater than 1 as well. Or you can return, of course, index 5 because that's number 6, which is greater than 5, and it's greater than 4. And that's basically what they say right there. Okay, so let's write the code. Okay, so we normally only ever use binary search on a sorted array, but we can use it here, and I'm going to explain it a little bit. I'm not going to get into this isn't going to be a mathematical proof of why we can use it here, but what we need to think about is this. So I'm going to do a few guard statements, and then it'll make sense a little bit more. So if the length of the array is 1, well, we don't even have to do binary search, right? And we just return 0 because that number is going to be a peak element because it's going to be greater than negative infinity on its left side, negative infinity on its right side. And we know that it's negative infinity because of that line. All right. But what we can also check is if nums.length, if the number at nums.length minus 1 is greater than the number at nums.length minus 2, well, then we can just return nums.length minus 1. Oops. And we can do this exact same thing except at the front of the array, right? And we just return 0. So the only time we're actually entering binary search is when there is not a peak at the beginning or the end. So what that means is that nums 0 would have to be less than nums 1, and then the number at the last index would have to be less than the number at the first index. Now, what that means is that there is going to be a peak somewhere in the middle, and that we can simply find it by doing binary search. And again, this is not a mathematical proof video. This is just a video how to code the solution. But now we're good to do binary search. So for binary search, we set the high and the low. And our iteration is, well, low less than or equal to high. It would never get to that point, and that's because we do these checks here. But that's just still how we iterate in binary search, and we can certainly just do that here. And now what we need to do is we can say we can make a mid equals low plus high minus low divided by 2, and that needs a semicolon, of course. And at this point, what we want to do is we want to check first, is nums at mid greater than nums mid minus 1, and nums at mid greater than nums at mid plus 1. And if it is, well, we can just return mid because that's a peak element. This is, in fact, the definition of a peak element if it's greater than the number on both sides. But if it's not, so we can say if nums dot mid, for example, is less than nums mid plus 1, Well, we can now just increase our low to mid plus 1. And now we can do the other way and check whether or not nums at mid is less than nums at mid minus 1. And if it is, well, now low is equal to mid minus 1. And eventually, before we finish this, we will find a peak. And we can just return -1 if we get down here, but we never will. That is why. And of course, this is why it's not working. Turn the thinking cap on. High needs to be equal to mid there, because we need to bring the high down. So that's why we got that problem, that infinite loop there. But now it should work. There we go. Alrighty, so that was the solution to find peak element. If you guys like that, like, subscribe. Today was day 25. We got another 75 days to go. See you tomorrow.